Okay, good morning class. So today we're looking at the exponents and surds. Solving equations with rational exponents. This is example 1 on page. Example 1 on page 11. However, it's for exercise 1.6. It's on page 13. Okay. To solve the equation with rational exponents, we need to ensure that the answer is a real number. Okay, the answer must be a real number. Remember, definition, the nth root of a to the m can be written as a to the m over n. Remember that the denominator will always be the root. Okay, the denominator there will be the root. So the nth root of will be the denominator in the exponent. We will use this definition to solve equations with rational exponents. Example, the cube root of a squared can be written as a to the 2 over 3. The cube root of b is going to be b to the 1 over 3. The fourth root of p to the cube is going to be p 3 over 4. And the square root of x, of course, is a 1. And the 2 there is going to be x to the half. By definition, the square root of 25 is 5. Negative square root of 25 is negative 5. And plus minus the square root of 25 is plus minus 5. I'm looking at the examples on page 11. This is the example on page 12. Now who told me 11? And this exercise on page 13. Huh? Okay. So the question says solve for x. Okay. So this here could be written as the square root of x, not so equals 3. Square root of x equals 3. How do I get x on its own? Square both sides. Not so. So x equal to? And you can test it. If I put 9 in here, 9 to the half, that's going to be 3 squared raised to the half. Multiply the exponents, it's going to give you. Not so. Alright. There's another way I could have done the same thing. If it's x to the half equals 3. What I do is, I raise this to the exponent of its reciprocal there. Just 2 over 1. Okay, and of course, that would simply give us 3 squared, which is 9. So x is equal to 9. Okay, you guys understand? Either or will be correct. However, if we look at number 2, okay, number 2, we have x to the half is equal to negative 3. But x to the half can also be written as the square root of x equals negative 3. Not so. So what do I do here? Square both sides, no? It's incorrect, but I'll show you now why. Square both sides. Then what are we left with? X is equal to? 9. But if you substitute this back in here, I should have gotten negative 3 out again. Not so. But if I say 9 raised to the exponent of, that will be 3 squared, which is half, which is 3. Is 3 the same as minus 3? No. So we'll make a note there. Okay? That from a square root, you'll never get a negative. Can you see that, people? From a square root, you'll never get a negative. Okay, so then you say no solution. So the first thing is, from a square root, you'll never get a negative. Or, we can say, if the denominator of the exponent is even. Okay, you can make a note there. If the denominator of the exponent is even, then the number on the other side must be positive. The number must be positive. If it's not positive, people, then it's going to be a no solution scenario. Okay? No solution scenario. Is even, yes. The denominator is even. And your number must be positive. Also, you must note that from a square root or even any even root, you'll never get a negative. Right, so let's look at number 3 now. Is the denominator even? No, it's odd. So does the rule apply here? No. So what do I do? If I got x to the third is equal to negative 1, what do I do? You raise it to the reciprocal, not so, which is 3 over 1. So that would be x is equal to negative 1. That's one way of doing it. Otherwise, I could change it to your third form. This would be what? The cube root of x is equal to negative 1. How do I get x on its own? Cube both sides to get rid of the cube root. So x is equal to negative 1. Okay? Simple, no? Alright, so let's look at the next one. X squared is equal to 4. Square root both sides, he says. Not so? Square root both sides. If I introduce the square root, what must I not forget? Plus minus. Always, no? Any even root, if I take it, is going to be plus minus. So x is equal to? Plus minus. Okay. Now what if I apply that other rule I told you earlier on? We got x to the r, x squared is equal to 4. And remember, if I apply another method, I must get the same answer. The answer must be the same. Eh? So if I take this and I multiply, what's the reciprocal of 2? R. And I take half on the side. But 4 can be written as what? 2 squared. So x, so that cancels. So the 1 is equal to 2 squared. Raised to the half. So x is equal to 2. People, is that answer the same? No. Okay, then you're shorting the other solution, which is the minus. No? So the plus, this is the plus one. So there's now another rule that's going to come into play here. For this answer to be the same, I'm shorting the plus minus. That's all. So the rule says, if the numerator is even, make a note there. If the numerator is even, if the numerator is even and I raise it to its reciprocal exponent, I raise the exponent to its reciprocal, reciprocal exponent, add plus minus to the other side. Add plus minus to the other side. People, please cover your textbooks, no? Please, the textbooks are very expensive. Okay? We waited a very long time to get it. Okay. Okay. You all understand, eh? So what are the two rules? If the numerator is even, then the number must be positive. Sorry, did I say denominator or numerator? Yeah. If the denominator is even, the number must be positive. So if it's negative, what happens? No solution. This one here. If the numerator is even, then I must introduce plus minus to the other side. You understand? Alright. So let's look at more sums here involving this here. Here we are told in summary, in an equation involving rational exponents, you've got x to the half, x to the quarter, x to the 3/2, by definition are positive or zero. Not so? That's why we just said, if the numerator is even, this number must be positive. If it's not positive, it's not going to work. Okay? Thus, the equations x to the half, x to the negative, x to the half is equal to -2, x to the quarter. You see, this is all even here. Will have no real roots or no solution. Okay, if it's a cube or any odd denominator there, it can be positive or negative. Okay. So let's look at example 1, and example 1 is on page. This is on page 30. Okay. The question says solve for x. We got x to the exponent 3/4 is equal to 8. Okay, so what is the rule if the denominator is even? The number must be positive. Is the number positive? Yes. Okay, so we can apply this. Right, so what do we do here? What do we do here? Sorry? Raise it to its reciprocal exponent. Not so. Raise it to its reciprocal exponent. And what's the reciprocal exponent here? 4/3. That must also be raised to 4/3. What you do on the one side, you must do on the other side. So of course this cancels, not so? So x equal to now 8 can be written as 2 to the exponent 3. Raised to the exponent 4. Now what? Cancel. So 2 to the 4 is equal to x. So x equal to? Okay. Is there any confusion here? You got it? Let's move on. Example 2. Example 2. So here we have x to the 2/3 is equal to 4. What's the rule if the numerator is even? Was add? Plus minus. Okay. So we raise this to its reciprocal exponent, which is what? 3/2. 3/2. We add plus minus. So x is equal to plus minus 2 squared raised to the 3/2. Okay. Now what? This cancels. That's going to be plus minus 2 cube. And 2 cube is? Okay. Is there any confusion here? No. Okay, so I'm going to give you a couple of minutes to do exercise 1.16. And then we're going to answer those sums down the board, okay? So with that, actually exercise 1.6, no? What do you guys tell me? What's wrong with you? Alright. So do that short exercise quickly and we'll do the answers to it now.